Today we're going to be doing section 5.1 and it's on verifying identities. I want you to know that this chapter is very different than chapter 4. You're not going to be finding exact values. However, all of the properties that we used before are going to still be in effect. So just to do a quick understanding of what I mean when I say this word verify. So again, the idea is you're not solving. You are never moving terms from side to side. So let's say I gave you this problem and I said verify that this statement is true. So notice there's no variables. I'm not solving. I'm not moving terms from side to side. I'm just simply trying to prove that the left-hand side is equal to the right-hand side. So I would say in the numerator I got 20 and that 20 divided by 2 is 10. And I have verified that these two statements are equal. So that's what I mean by verify. So next I'm going to put up on the screen all of the identities that you're going to need to know for this section. You already have them written down in your notes, but if for some reason you can't seem to find them, use this moment to pause the video and copy them all down. So here are your reciprocal identities, your quotient identities, and your Pythagorean identities. So all three of these sets of identities you're going to be needing for this chapter. The other ones that I don't have on here are the even and odd identities, and those are the identities that say the negative goes out front for sine, cosecant, tangent, and cotangent. Cosine and secant is when the negative goes away. So again, that's your even and odd identities. If you need to, pause this video, copy all these identities down. Alright, so we're going to get into doing a few examples today. Again, this is something I recommend writing down. If you're going to watch it, I would watch it and also write it down and then maybe watch it a second time. But this is something you want to have because this is very different than anything we've ever done before. Alright, so the problem is we have secant of x times cotangent of x and I'm trying to prove that this is equal to cosecant of x. And we're going to start off with a very easy one just to kind of introduce this to you. The strategy is you always work with the more difficult looking side and you're trying to make that side look like the right side. Another strategy is to always get all your terms into terms of sine and cosine. So for example, the secant I have right here, I would want to change to get a cosine or sine into the problem. So secant is the same thing as 1 over cosine of x. And that's going back to the idea that it is the reciprocal of secant. Now cotangent is the reciprocal of tangent, but that doesn't give me a sine or cosine. So I would want to go with the quotient identities and say cotangent is cosine over sine of x. And we know when we multiply fractions, we multiply straight through top, straight through bottom. So I'm going to get cosine x all over cosine x sine x. And now I can see that I have a cosine in the top and the bottom. So each pair is going to cancel out respectively, so the cosines are gone. And now I have 1 over sine of theta, or sine of x. And using the reciprocal identities, I know 1 over sine of x is equal to cosecant of x. So notice I have proved that the left-hand side is equal to the right-hand side. So let's try another one. So this problem, our example is tangent of a negative x times cosine x is equal to negative sine of x. So again, you want to start working with the more difficult side. So the left-hand side is clearly the more difficult of the two. So first I'm going to address the even and odd. So tangent, when there's a negative on the inside, we know the negative goes out front. So this will become negative tangent of x times cosine of x. And now that I handle the negative, now I need to get rid of tangent. I could say tangent's 1 over cotangent, or I could say tangent is sine over cosine. And I would want to go that route because I always want to introduce a sine or cosine into the problem if possible. So the quotient identity says that tangent is sine over cosine. And now I'm multiplying that by a cosine of x. And again, we're going to multiply fractions. Technically, this is like a cosine over 1. So I have negative sine of x times cosine of x is all over cosine of x. So my cosines are going to cancel, and I'm left with negative sine of x. And notice that I have now proved my identity because I have the same thing on both sides. So that's how you know when you're done, when you got the left-hand side, or whichever side you started with, to look like the other side. So we're going to do 2 more examples for today, and then we'll be done. So next one, example, we have sine of x times tangent of x plus cosine of x, and this is equal to secant of x. So again, we start with the more difficult side, so we're starting with the left. My first term's sine, so I'm going to keep that. I already have a sine there. I'm going to change this tangent to be sine over cosine. And this plus cosine, well, that's already in terms of sine or cosine, so it stays. So I need to multiply this fraction over here. So I'll get a sine squared of x. Notice when I'm multiplying, it's the sine that gets squared, not the x. And now if I want to add these 2 terms together, I need to have common denominators. So I know this is over 1. I need to have a denominator of a cosine. So I would multiply this top and bottom by cosine of x so that I can add these 2 terms together. So I have sine squared of x over cosine plus cosine squared x over cosine. And the whole purpose of getting common denominators is so that I can put it together. So I'll have sine squared of x plus cosine squared of x all over cosine x. And now the last thing that we would use is the Pythagorean identity. So if you're looking at Pythagorean identity, notice that so I can remove sine and I can replace it with 1. So this right here is equal to 1. So I can say this is 1 over cosine of x. And 1 over cosine of x, that is the reciprocal identities, and that is equal to secant. So notice I have proved that the left-hand side is equal to the right-hand side. This problem is clearly a lot more involved than the other ones that we've done. So I'm actually going to pause there today instead of doing one more example. Again, please make sure that you write this down so that way you have something to look back at when we do this in class tomorrow. All right, that's all for today.